So hey guys, so today we are back with another ML news episode. This is the episode 3 and the week 3 of the series. So a lot of updates this week. We haven't got any very major update this week because of the maybe the previous 2 weeks where we had models like Llama 2, 5, the Llama 3 model, the 5.3 model, where those two models took the hype of all the other research papers and happenings of that week. So this week we'll start with the OpenAI's update. What OpenAI said that now memory feature is now available to all the Plus users from 29th April. So they say it's now available to all ChatGPT Plus users except in Korea and Europe. I don't know the reason why they haven't enabled it there. So using memory is easy. Just start a new chat and tell GPT anything you would like to remember. So memory can be turned off or on in settings. So people who don't know about memory, so a few weeks back, actually few months back, that is 2.5 months back, OpenAI released a blog that how memory works. So if you see in this example, you will be asked in the settings personalization memory section where you can tell GPT few things to remember for you, like when is your birthday, what is the anniversary date of you and the work where you started your life, similar things. And then you can also go and turn off that feature if you want. You can even clear the memory so that the model doesn't know explicitly about any one thing. And you also have temporary chat option where the model won't have any memory of this, so that you every time don't have to go and clear and delete the memory. So yeah, this feature is now enabled on all the ChatGPT Plus users. So if any one of you who is using ChatGPT Plus, do use it and give your feedback of how this particular thing is working out. To be honest, I'm pretty excited for this. I am not a GPT Plus user, but I guess for this particular feature to use, I may have to switch myself from a normal account to premium account. So the next thing is the GPT-2 chatbot. This week there was a whole mystery thing that happened. So I think 2 weeks back, I think 7-8 days back, the CTO of OpenAI, Sam Altman, wrote, I do have a soft spot for GPT-2, and I definitely wrote that definitely something is being fishy here. So and if you read this article from the Forbes website, you will get to know that the Chat GPT-2 bot was there on this inference page, where you can actually compare two chatbots results side by side. And so GPT-2 chatbot was there for a while. And if you see some YouTube videos which were recorded at the time this was available, right now they are saying GPT-2 chatbot is currently unavailable. So they haven't mentioned any particular reason for that. But the OpenAI GPT-2 was able to outperform the GPT-4 results. I don't know how that was possible, but if you see some tutorials that were there, some people testing it out, it's actually outperforming some of the existing GPT-4 questions, which were pretty hard, right? And it does, however, appear to fall short of what would be expected from OpenAI's GPT-5 model. So maybe they had added some new features to GPT-2 model, but were they that good that it was able to outperform the GPT-4? We don't know, because it's not available now. So even Forbes asked the OpenAI about this. OpenAI did not immediately respond to Forbes' request for comment on this chatbot. So it was a mystery, and I think will remain mystery for a while till we get to know that okay, what's the next step that the company is planning to take. And currently it's not available, so it's really sad that we were not able to record that time. But if in the future, in the coming week, we get this available, I will definitely make a video on this and how it's performing. So pretty excited for this. Let's now jump to Jamba. So if you guys remember, few months back we had the Jamba model. So it's a hybrid of the SSM and transformer model. So if you guys don't know about this, I would recommend you guys to go and read the Mamba paper. So Mamba was a counter framework to the transformer model that is currently there. So the architecture looks like pretty straightforward, the state space model. And it was showing that in some cases, especially to the quadratic equations of the transformer model, it was able to be better in that case. Even though coming to results, it's able to sometimes outperform the existing model, but transformer is still, I think, the best in the market, and maybe some changes in the SSM architecture will be needed to achieve the state of the art performance, right? And so this week they have released the Jamba instruct model. So it's just the instruct version of the Jamba which they released, I think, 1 month back. So the results look very good. So if you guys don't know about this, so Jamba also actually is sort of a very high parameter model, because if you see there, so they are saying 3x throughputs on long context compared to mixed trail model. And if you go down, you'll see the architecture of the whole model. You have the transformer layer, then you have the tension plus MOE layer, the Mamba layer, and the Mamba plus MOE layer. So different types of the layers that were used by the Jamba architecture. And if you see the efficiency, you'll see the Jamba model maximum context length on a single GPU is pretty good. So yeah, and if you see here the number of the context window right now, so Jamba is having the best in this case. But the whole point is, until unless we use this, we can't be pretty sure, right, that how it's performing. Now the Jamba instruct model is there, we can have a comparison of how it's doing. So if you see here common benchmarks, so on the MMLU benchmark, it's not able to outperform, but yeah, it's performing pretty decent to the Llama 3 8 billion. And from the comparison with the mixed model is obviously worth. So on all of the other like GSM 8K, Hello Swag, Winogate, and the Arc Shell, no, not in the Arc Shell, in these three, it's able to outperform the mixed and the Llama 3 model. And in the Arc and MMLU, it's I think it's on the second position. Comparison with Llama 3 8 billion, I think won't be fair. They could have taken the bigger model, but okay, let's keep it till here. Now, if you see the context window of Jamba 3 is pretty big, right? It's a 256 context window, so it's huge. And if you look at the long context QA benchmark, you'll see that Jamba is performing pretty well compared to the mixed model also. So you can actually we can test it here. So I have some charts. So I ask this, that one shirt takes 5 hours to dry on a hot day. How much will 5 shirts take? So this question was pretty much asked to every GPT model that it was released at that time, and it used to fail. Even I think if you add some more twist to this question, GPT-4 will still fail. So Jump Instruct is able to answer it very straightforward, that it will if one shirt takes 5 hours, then 5 shirts will take the same amount of time. So looks good. And I will give you the link to all these trying models on the description as usual. You guys can go and try, and they're providing a lot of different things. So even you have the RAG engineer. If you want, you can try this. You can upload the documents, and then you can chat with the model, and it looks decent. Are they trying to get into the market of the whole RAG chatbot inference pipeline? I don't know, but they have enabled all the features for trying now. So you guys can go and try this, and like share how good you think these models are. Cool. I think we'll move to the next segment, that are random and small news updates. So this week on Hugging Face, another quantization method dropped, that was half quadratic quantization. So HQQ implementations on the fly quantization is very robust optimization. So you see here, we are now able to quantize any model up to 1 bit precision. I don't know how good this is going to perform. We will have to test, but yeah, it's available now. 1 bit precision is a reality now, even though it was available through some third-party libraries, but now it's integrated in the transformers library. Now you can set the HQQ configuration, and the n bits is equals to 1, and you're good to go. So let's try. We'll definitely try this 1 bit quantization and see how it performs. I don't have much hopes that it'll be able to outperform the existing ones, any existing benchmarking that was done on the quantization part. But yeah, let's see. It's pretty good. Now the second is AILM has made again a very huge news, that you can actually load the Llama 370 billion model on a single 4 GB GPU card. We are doing no quantization, no distillation, no pruning, or any other model compression technique. So I think 3 weeks or 4 weeks back, they made an announcement about the Mixtral model, that the new Mixtral model, that you are able to now put this on a single GPU. And even during the release of the first Mixtral initial model, they made a news that you can actually put the whole model on a single GPU. And I think I tried that at that time, and the results were decent, right? I won't say they were the same, but they were decent. And if you look at the current code, in just 20 lines of code, 10 to 15 lines of code actually, you can put your whole model into a single GPU card. So it's really decent. And AILM, I don't know how they are doing this thing at the back end. I will go through their code base once, but if this is able to even achieve 80 to 75% of the original model, it's decent. A 70 billion model on a 4 GPU on a single 4 GPU card, it's awesome, right? Now the next thing is, it's kind of a research paper only, but I decided to keep this in the small news segment to because the LinkedIn post is more than enough to summarize the whole research paper. So the research paper is better and faster large language models through multi-token prediction. So it's a very good research paper. I will just give you some summary of this. So this whole post revolves around the whole theory of no free lunch theory, right? So if you quantize your model to improve the speed or reduction, it will cost you accuracy. That's very pretty straightforward. So Meta says no thanks, let's keep the 3x speed and a plus 10% accuracy by removing the next token prediction. So yeah, so how they did it? So Meta found that training models with multi-token instead of the next token prediction can actually help you achieve this. And they have even achieved a 17% boosting performance on human evaluation and 12% on MBPP. Now the method that they've used, the modified architecture with the shared model trunk with the multiple prediction heads. You, I think, saw that thing here. So yeah, this is the one. And each prediction head predicts a different future token. Now the train model is from 300 million to 13 billion using 1 trillion code tokens. Now if you go through the Llama 3 blog, you will get to know they have the trained on 1 trillion tokens, and this actually is going against the neural scaling laws that were defined in 2-3 papers after the GPT model got released. So it actually breaks the loop that we have been following of the number of tokens that need to be trained. And 13 billion model had a plus 17% on MBBP and 12% on the human evaluation. So this paper is pretty awesome, and this LinkedIn post is more than enough to summarize the overall from top of the view of what this paper is going to tell you. So I will link down both of them in the description. You can go and read it from there. Now I'll take things fast. So the top 3 research paper of this week are Wild GPT. So this dataset looks amazing. What they have done, that they have given the access to GPT-4 and ChatGPT to a few lakh of users, and then they got a corpus of 1 million ChatGPT conversations. Now if you look at the quality of conversation, you can see from here the number of conversation is highest, 1 lakh, I think 10 lakh 39,000, and Alpaca was 52,000. And if you look at the users, it's pretty high, 2 lakh 4,000, and the number of tokenization is 295.58. So it's obviously in a very huge number when compared to the current one, 19.67. Now the chatbot is also the same, the highest one, and the languages are 68. So this data set looks amazing. And if you see the distribution over this, so you will see that a lot of people from different countries were there. So you will see some diversity in the chat quality. And if you go down here, you will see the number of conversations per model over time. So highest was, I think, GPT 3.5 Turbo 0125. So this was the highest. They ran it for 1 year, I guess. And English 56 was the open assistant, and shared GPT was 92.35%. That's the reason shared GPT dataset is considered a bit biased towards English, and while chat is only 52%. Rest it has Chinese, Russian, Spanish, German, and French, and 15% to other. That is the highest among here, right? And if you look at the percentage of toxic turns, I think chatbot 0.02%, and the white chat is 5.18%. So it's pretty high. But yeah, the dataset size is also big, and I think we can filter that out. That's not a thing to be concerned about. Yeah, so I'll link down the paper to the description, and this is the website where you can go and look at the dataset quality. Now the next paper is the from LoRaWAN. So they are saying that 310 fine-tuned LLMs that rival GPT-4, a technical report. So the main thing is, if you look at the current diagram that they have provided here, you'll realize, right, the fine-tuned model and the base model, they have done this on a number of things. Now if you see, LoRa is a popular technique we all know for efficiently fine-tuning LLMs, right, with fewer parameters, less memory usage while maintaining the performance. Now this particular paper will tell you that across various task and base model, finding that 4-bit LoRa actually fine-tuned outperforms the existing one. You see here, right? we find that 4-bit LoRa fine-tuned models outperform base model by 34 points and GPT-4 by 10 points on average. Now, second thing are they saying, we investigate the most effective base models for fine-tuning and assess the correlative and predictive capabilities of task complex heuristics. Now, this particular study actually talks about LoRax, that an inference server that facilitate the deployment of multiple LoRa models, and this is a kind of survey paper. But if you go through this, right, you will realize that they have not only done this on a few models, but they have tried this on a number of models, and the results look amazing. You see here, they done this on all of these models, and the results are amazing. So the 4-bit model are actually outperforming some of the existing model, the 4-bit fine-tuned models. And if you look at this, so these are the configurations they are giving. So they are allowing you to go and actually test this yourself and check that if this is outperforming the current model in your case. So yeah, now the next model, the next paper is Prometheus 2. So an open source language model specialized in evaluating other models. So this particular paper is actually discussing the challenges in the evaluating LLMs, and introduces the Prometheus 2, an open source language model, specializing only in the evaluation part, they are saying. So the current existing LLMs are very biased, or you can say they have the whole the complex of being biased towards the models which are coming under the same category. If you see, GPT-4 is definitely going to be biased towards GPT 3.5 compared to the Llama models. So these weak evaluators achieve low score correlation with the strong evaluators. On the other hand, the scores provided by these evaluators are highly correlated with the other bias. So Prometheus 2 is saying that they are addressing these issues by closely checking the human and GPT-4 judgments, supporting directly pairwise ranking formats with custom evaluation criteria. So this is one of the example they are saying. So the two things are the pairwise ranking and the direct assessment. And what they are saying, it outperforms other open evaluation benchmarks that are right now. So if you look down here, yeah, you will see that Prometheus 2 is a 8 into 7 billion. So they are following the same 46 billion or 56 billion parameter architecture. And the results are decent because they are able to outperform the existing direct assessment results. So they have used the Pearson correlation between the reference evaluators and the evaluators language models. So yeah, so this paper is also talking about that whole concept that currently evaluation is one thing that we are relying on GPT-4. And actually the nepotism bias which has been there is causing a lot of benchmarking biasness, because you will see, if you're using a particular model for evaluating the other model of the same dataset trained, then there will definitely be a nepotism bias. So yeah guys, that was it from my side. I will pin down all the resources in the description. Do give them a read and like the video if you guys liked it. Thank you and have a nice day.